Welcome back to Soil Doctor, where we dig deep into the science that makes your garden thrive. Today we're examining why passive composting isn't just easier. It's actually more effective than traditional high-maintenance methods. The research might surprise you. When you constantly turn compost piles, you're disrupting established microbial communities that are perfectly designed for decomposition. Soil scientists have discovered that undisturbed compost develops distinct zones with specialized bacterial populations. The outer layers house aerobic bacteria that break down fresh materials, while deeper sections contain facultative anaerobes that handle more complex compounds. This natural stratification is destroyed every time you turn the pile. Recent studies from agricultural universities show that passive compost systems maintain more diverse microbial communities. These diverse populations create more stable humus compounds and retain nutrients more effectively than frequently disturbed systems. The lazy approach isn't laziness, it's working with natural soil biology instead of against it. Traditional composting wisdom says you need high temperatures from frequent turning, but soil thermodynamics tells a different story. Passive piles develop what researchers call thermal gradients, different temperature zones that optimize different stages of decomposition. The center reaches 130 to 140 degrees Fahrenheit naturally through microbial activity, while outer layers stay cooler, preserving beneficial fungi and slow decomposing organisms. This temperature variation actually accelerates overall decomposition because different materials break down optimally at different temperatures. Proteins decompose faster at higher temperatures, while cellulose and lignin benefit from the slower, fungal-dominated processes in cooler zones. You get complete decomposition without the energy expenditure of constant turning. The layering method creates what soil chemists call microenvironments with varying carbon to nitrogen ratios. Rather than trying to achieve a perfect 30:1 ratio throughout the pile, layering allows for optimal ratios in different zones. Fresh green materials in thin layers provide nitrogen for microbial growth, while thicker brown layers provide carbon for energy and structure. This approach prevents the nitrogen volatilization that occurs when organic materials are overmixed. Laboratory analysis shows that layered systems retain 15 to 20% more nitrogen compared to frequently turned piles, resulting in more nutrient-dense finished compost. The physics of water movement in layered organic matter creates natural moisture regulation. Coarse materials at the base establish drainage while creating capillary channels that wick moisture upward during dry periods. The alternating layers of absorbent browns and moisture-rich greens create a buffer system that maintains optimal 50 to 60% moisture content with minimal intervention. This natural moisture regulation prevents both anaerobic conditions, which cause odors, and excessive drying, which halts decomposition. Soil physics research confirms that this passive moisture management is more stable than manual watering systems. Perhaps most importantly, undisturbed compost allows beneficial fungi to establish extensive hyphal networks throughout the pile. These fungal networks, similar to mycorrhizal associations in forest soils, dramatically improve nutrient cycling and create the complex soil structure that plants crave. Microscopic analysis reveals that passive compost contains 300 to 400% more beneficial fungal biomass than turned compost. This fungal dominance creates the rich, crumbly texture and earthy smell that indicates truly mature compost. The science is clear: lazy composting isn't just easier, it's biologically superior. By working with natural soil processes instead of fighting them, you create better compost with less effort. Remember to subscribe to Soil Doctor for more science-based gardening insights, and share this video with fellow gardeners who want to understand the why behind the what. Until next time, keep digging deeper into the science of soil.